All right, so let's continue with 6-3 now. So this is 6-3, day 2. And we're going to pick up where we left off. We were talking about second partial derivatives, and that mixed partials were expected to be the same. And the reason why is because we're going to look at the discriminant. Okay, so the discriminant is something you're going to have to memorize. And it seems so easy, and you're going to be like, hey, I don't really need to memorize that. I'll be fine. I have it written down, and luckily you guys will probably have this as something written down in your notes, but if you memorize it, it'll make things go faster. All right, so you're going to take the two partial derivatives. One is the second partial with respect to x, the second partial with respect to y, and then you're going to subtract the mixed partial squared. Okay, so it doesn't matter which mixed partial you do because, again, they're exactly the same. Okay, so in example 6-3-4, we're going to find the discriminant of the last example we did on the first day's notes. Okay, so again, this was, we ended up with fxx was 2, fxy was 3, and fyy was 30y. Okay, so we're just going to plug it into the formula. Nothing too bad here. All right, so when I plug it into the formula, I'm going to get 2 times 30y minus 3 squared. I get 60y minus 9. Okay, this will come in handy in a minute. All right, so we have a couple of things we're going to look at here in the text. Let me pull it up. All right, so normally when we do the section, I give you a big worksheet where we fill in the blanks. And this discriminant test is actually just printed out on it. So if we look up, you'll see that it's titled the Discriminant Test. Okay, so the first thing it says is we have to let the point be a critical point of fxy. And then it says if the discriminant of AB is greater than 0, so if we get the number to be greater than 0, then we have to look at the partial with respect to x. Okay, it's a local minimum, it's a local maximum if it's less than 0. Okay, so we're going to have to look at this chart in order to do it. Okay, so I'll talk it through because I already know the chart, I've memorized it. Obviously, you don't have to memorize it. My students in a regular semester do have to memorize it. But you will have open notes, so you might as well have it, an open textbook. So no big deal. So we're going to go to this chart, and we're going to classify what's going on here. I don't know that I could mark this up. That'd be great if I could, but I don't think I can. No. Nope. All right, so we're going to start with the first problem. And the first problem gives me fx and fy. They're both 0. Okay, so the first thing we did on the first day was we said that fx has to equal 0 and fy has to equal 0. And then we're going to use our formula, fxx, fyxy, and fyy. Okay, so let me go to the whiteboard and we'll calculate it out and then we'll talk it through. All right. So on my chart, it said fx was 0, fy was 0, fxx is 0, fxy is 0, and fyy is 1. All right, so When I do this, I'm going to, again, take my formula, my discriminant formula. So I get fxx is 0, fyy is 1, minus fxy squared, 0 squared. So I get 0 minus 0 equals 0. Go back and look at your chart. Okay, I don't want to pull it up now because it'll erase everything. But the chart says if the discriminant is equal to 0, we don't have enough information to classify the point. So we would put not enough info. And we showed our calculations. You're going to have to show your calculations on these tests. All right. So this is A. I'll write them out. You might want to just pull it out from your textbook while we're doing this. Fx equals 0. Fy equals 1. Fx equals x equals 2. Fxy equals 3. And Fyy equals 4. Okay. One thing I want to point out that I like to do right away is that if this equals 1, automatically you can tell me that it's not a critical point. But I still can classify the discriminant. So I still can go 2 times 4 minus 3 squared. So I get 8 minus 6 gives me 2. So that might give me pause there. I'm like, well, I got a number, so I should be able to use the chart. But again, Fy equals 1. We said in the beginning, this has to be 0. It's not, so it's not a critical point. All right, so let's look at C. And we get Fx equals 1, Fy equals 0, Fxx is 0, Fxy is 2, Fyy is 3. Okay, again, this equals 1, has to be 0. Also it has to be 0. So it's going to be not a critical point, but I'm still going to do the multiplication. 0 times 3 minus 2 squared equals 0 minus 4 gives me negative 4, but it's not a critical point. Be careful. Those are always lurking. Not a critical point. All right. So let's do a couple others that are going to pop up. Okay, so D gives me Fx is 0, Fy is 0, Fxx is 1, Fxy is 2, and Fyy is 0. Let me fix this one up here. That was supposed to be 1. There we go. So our initial conditions are met. We're going to do 1 times 0 minus 2 squared. 0 minus 4 gives me negative 4. Any negative point, this is the student's favorite normally. Anytime you get a negative, you get a saddle point. There's no other work involved. You just go, hey, it's negative, it's a saddle point. All right. E's going to give you a saddle point as well. So we're going to skip that one and we're going to go to F. All right. So Fx is 0. Fy is 0. Fxx is negative 3. Fxy is 1. And Fyy is negative 2. Okay. So we're going to do negative 3 times negative 2 minus 1 squared gives me 6 minus 1, which is 5. Okay, anytime you get a positive, you then have to check f(x)(x). Okay, f(x)(x) is going to change things. So if f(x)(x) is greater than 0, you get a minimum. Sorry, brain kind of went out for a second. You get a minimum. Okay, so our f(x)(x) is not greater than 0. It is less than 0. So if your f(x)(x) is less than 0, you get a maximum. So that's what we have. We have a maximum. So our answer on this one is max. Okay. G will also give us not enough information. We get 0. Okay. So what we're going to do now is one big problem that's going to look like what happens on the homework and what's going to happen on the classwork. All right. So, oops, I do not want blue. Let's do black. Example 636. f(x,y) equals x cubed minus 3x plus y cubed minus 3y squared. Okay, the problem says find the critical points and classify them using the discriminant. The first thing that I ask you is partial derivatives. So let's find the partials. f(x) equals 3x squared minus 3. And fy is 3y squared minus 3y. Okay. B is going to ask for the critical points. Okay. So to find the critical points, we're going to set them equal to 0. These ones aren't going to work for systems of equations, but we can still set them equal to 0 and they still will solve out. They just don't have both x's and y's. All right, so this one I'm going to solve for x squared. X squared equals 1. Take the square root and be careful because x equals plus minus 1. This one I'm going to factor 3y out. Y minus, oops, I made a mistake. I just looked at my paper. It happens. You know it happens to me a lot. This is going to be 6y. Let me erase. (6y). So this is also 6y, and this is supposed to be 2. All right, so then each piece gets set equal to 0. Y equals 0 and y equals 2. All right, so before I just got one coordinate as a critical point. Now I actually am going to have to set up several points for the critical points. Okay, so I have x is 1 and y can be 0. I also have x can be 1 and y can be 2. I also can have x be -1 and y be 0, and x be -1 and y be 2. So I have 4 critical points. 4 critical points. Okay. Then I ask you on the classwork, and you saw this the other day, you're going to graph. So hopefully you have a good handle on that. Okay, we're gonna classify them next. Okay, so now we're gonna classify. Okay, to classify, we're going to now have to find f(x)(x). f(x)(x) off of 3x squared minus 3 gives me 6x. f(x)(y) gives me 6y minus 6. And fxy gives me 0. Okay, so my discriminant is 6x times 6y minus 6, which gives me 36xy minus 36x. It's not a number. So I'm going to have to worry about plugging all these coordinates in. So let's start off with 1, 0. Okay, if I plug in 1, 0, 36 times 1 times 0 minus 36 times 1 gives me negative 36. Again, anything negative is going to give me a saddle point. All right, then I had 1, 2. Plug that in. 36 times 1 times 2 minus 36 times 1 gives me 72 minus 36 gives me 36. Positive. Check. fxx. Well, fxx is 6x. So 6 times 1 gives me 6. It's positive, so I get a minimum. All right, let me go to another page for the other two. All right, so I had 1, 0. I had 1, 2. Let me do negative 1, 0. Gives me 36 times negative 1 times 0 minus 36 times negative 1. 0 plus 36, sorry, equals 36. So I got another positive number. fxx is 6x. So I get 6 times negative 1 gives me negative 6. So I get a maximum. Then I'm going to do negative 1, 2. 36 times negative 1 times 2 minus 36 times negative 1. I get negative 72 plus 36 gives me negative 36. And that's a saddle point. So it takes quite a while to do these problems because you have to do all of these pieces and all of the work and show the work and plug it in. So this stuff takes a little while. It's not hard, but it does take a while. So make sure that you really understand this. So I suggest to do, let me go to a new page for the homework here. So do the web work. Okay, there's only 2 problems. Okay, it was really hard to keep the problems on this one. Okay, but there are 2 problems. So go ahead and do the 2 problems. And then go back to the textbook 1 through 4 and do the last bullet point. Okay, you want to make sure that you are fully prepared because the quiz is on Wednesday. Let me see what date that is. Wednesday, the 8th. Okay, anything from 6-1 to 6-3. Okay, and we've been learning quite a bit. So make sure that you have everything on top of it. Okay, let me know if you have any questions.